derive an expression for the equilibrium constant and its units applying, state the necessary condition for the equilibrium and the ways that equilibrium can be recognized, and write the equilibrium constant expression of the reaction. ठीक है, तो यहाँ से हमारी बात शुरू होती है कि ये क्या है, ये सब कुछ क्या चीज़ें हैं, ये क्या हमें कह रहे हैं, क्या है स्टूडेंट आउटकम, लाइक व्हाट इज़ दिस एंड व्हाट इज़ ऑल एंड एक्सेट्रा। तो बात ये है कि इसमें ज़्यादा कुछ नहीं है, बस हम इंट्रोडक्शन की तरफ आ जाते हैं। इंट्रोडक्शन में हमारे पास आ जाता है जनरली वी presume that most chemical and the physical changes proceed to completion. A complete reaction is one in which all reactants have been converted into products. However, most chemical reactions do not go to completion because products react themselves to form the reactants. As a result, after some time, no further change takes place. Quantities of reactants and products remain unchanged, and it seems that the reaction has stopped. In fact, these reactions do not stop, rather they take place on both directions at equal rate and attain the equilibrium state. Such reactions are called reversible reaction. Many examples of physical and chemical equilibrium are found in nature. तो ये हमें बोल रहे हैं कि लाइक ये हमें क्या बोल रहे हैं, ये हमें क्या बोलना चाहते हैं, और ये आई एम रियली वेरी सॉरी फॉर दिस। तो ये क्या हमें बोल रहे हैं, क्या बोलना चाहते हैं और क्या इनका मकसद है, हम सब बताएंगे आपको। ये बोल रहे हैं कि वी ओ आर एग्जिस्टेंस टू इक्विलिब्रियम फिनोमेनन, ठीक है, टेकिंग प्लेस इन एटमॉस्फेयर। वी इनहेल ऑक्सीजन एंड exhale carbon dioxide while plants consume carbon dioxide and release oxygen. This natural process is responsible for the existence of life on the earth. Many environmental systems depend for their existence on delicate equilibrium phenomenon. For example, concentration of gases in lake water is governed by the principles of equilibrium. The lives of aquatic plants and animals are indirectly related to the concentration of dissolved oxygen in water. सबसे पहला हमारा टॉपिक है जो हमारा इनकी तरफ से है, वो है, अल्लाह आपका भला करे, irreversible and reversible and dynamic equilibrium। सॉरी, बुक थोड़ी ख़राब हो गई है, एक सेकेंड। जी, तो इसमें हमें वो बोल रहे हैं कि in a chemical reaction the substances that combine are called reactants and new substances formed are called products. For example, when H2 and O2 reactants combine, they form H2O. जो कुछ भी मैंने बोला आप लोग याद कर लें, इतने फिर लाइक अजान भी हो जाएगी, तो इतने आप याद कर लें। तो आप लोग याद करें फॉर्मूला 2H2 + O2 = 2H2O। ये फॉर्मूला याद करें जल्दी से। याद कर लिया होगा आप लोगों ने। अब चलते हैं हम आगे। अच्छा, मोस्ट ऑफ द रिएक्शंस इन विच द प्रोडक्ट्स डू नॉट रिकम्बाइन टू फॉर्म रिएक्टेंट्स आर कॉल्ड इरिवर्सिबल रिएक्शंस। दे आर सपोज टू कंप्लीट एंड आर रिप्रेजेंटेड बाय पुटिंग अ सिंगल एरो बिटवीन द रिएक्टेंट्स एंड द प्रोडक्ट्स। On the other hand, reactions in which the products can combine to form reactants are called reversible reaction. These reactions never go to completion. They are represented by a double arrow between reactants and products. These reactions proceed in both ways, therefore they consist of two reactions, forward and reverse. So a reversible reaction is one which can be made to proceed in either direction depending upon the condition. Let us discuss a reaction between hydrogen and iodine. Because one of the reactants, iodine, is purple, while the product hydrogen iodide is colorless. Proceedings of the reactions are easily sorry are easily colorless hydrogen iodine, such as formula आ गया colorless hydrogen iodide का H2 plus I2 plus purple is equal to S1 colorless. Therefore, this reaction is called as forward reaction. On the other hand, when only hydrogen iodide is heated in closed flask, purple color appears because of formation of iodine vapor such as 2S1 S2 plus L2. In this case, hydrogen iodide such as act as reactants and produces hydrogen and iodine vapors. This reaction is reverse of the above, therefore it is called as reverse reaction. समझ गए होंगे आप लोग? This reaction is called reverse reaction. अब हम बात करेंगे irreversible के बारे में। हमने अब रिवर्स के बारे में बात की, irreversible के बारे में बात करेंगे हम। तो on the other hand, when CaCO2 is heated in the open flask, it decomposes to form calcium oxide and carbon oxide. CO2 escapes out and reaction goes to completion. In these two reactions, decomposition is reversed to combination or vice versa. When calcium combination is heated in the closed flask so that CO2 can't escape, but shown in figure 2.7. So next में देखते हैं। नेक्स्ट में हमारे पास है रेट ऑफ फॉरवर्ड रिएक्शन इज इक्वल टू रेट ऑफ रिवर्स रिएक्शन। इसमें हमें गिवन है इन अ रिवर्सिबल रिएक्शन डायनामाइट इक्विलिब्रियम इज एस्टैब्लिश्ड बिफोर द कंप्लीशन ऑफ रिएक्शन. इट इज रिप्रेजेंटेड ग्राफिकली at initial stage. The rate of forward reaction is very fast and reverse reaction is taking place at a negligible rate, but gradually forward reaction slows down and reverse reaction speeds up. Eventually both reactions attain the same rate. It is called dynamic equilibrium state. So इसके बाद हमारे पास आ जाता है in the beginning, as the concentration of the reactants is higher than that of products, the rate of the forward reaction is faster than the reverse reaction. As the reaction proceeds, the concentration of reactants will gradually decreases while that of product will increases. It will be continued increasing and ultimately the two rates will become equal to each other. Thus, equilibrium will set up and concentration of various species becomes constant. It is represented as H2 plus H2 plus 2H1. So, macroscopic characteristic of forward and reverse. The forward reaction, it is a reaction in which reactants react to form products. It takes place from left to right. At initial stage, the rate of forward action is very fast. It slows down gradually. Reverse reaction, it is a reaction in which products react to produce reactants. It takes place from right to left. In the beginning, the rate of reverse reaction is negligible. So that it's all microscopic characteristic of dynamic equilibrium. An equilibrium is achievable only in a closed system in which substances can neither leave nor enter. At equilibrium state, a reaction does not stop. Forward and reverse reactions keep on taking place at the same rate but in opposite direction. At equilibrium state, the amount of reactants and products do not change. Even physically properties like color, density, etc. remain the same. An equilibrium state is attainable from either way, therefore starting from reactants or from products. An equilibrium state can be disturbed and again achieved under the given conditions of concentration, pressure, and temperature. Why reversible reaction never complete? Law of mass action. Kullberg and Weig in 1869 put forward this law. According to this law, the rate at which a substance reacts is directly proportional to its active mass, and the rate of the reaction is directly proportional to the product of active masses of the reactant substance. So मिलते हैं नेक्स्ट वीडियो में नेक्स्ट कंटेंट के साथ.